All right, kiddos. Guest appearance today by at
Miss
KSteve
Stevenson.
320.
KSteve 320. Find the derivative. I love derivatives. Y equals the inverse tangent of the square root of 11x.
So inverse tan, arctan.
I've got that on a piece of paper right here.
If you get
yellow piece of paper.
Get your yellow sheet out.
Yellow
if
sheet.
you're in my class, if you're somewhere else across the world, maybe you'll make your own yellow sheet. But
maybe.
Basically, on this sheet, we've got all our different derivative rules, and so this one is the arctan rule. So when I do dy dx, I'm going to use the arctan formula, and right over here, I'll just write it out real quick because it will help us guide our next thoughts. So if I go with d dx of the arctan of u, then that's going to be 1 over u squared, 1 plus u squared, du dx.
Du dx, yeah. Now I notice there's a difference in what we have and what is in the formula. For example, we have a square root of 11x instead of a u.
There it is right there. So u is going to be square root of 11x, or equally 11x.
To 1/2.
Genius.
Yeah, okay,
I was going to
cool.
say that. You beat me to the punch.
Cool.
So little mini chain rule action here, but it should be not too hard for us. We should be able to catch this now. We're getting to be professionals. So 1/2 times.
Multiply and subtract the power.
And then times the derivative inside, which is 11.
Right.
So this would actually end up being 11 over 2 times the square root of 11x.
Because
so
11x to negative 1/2, you just move it to the bottom and then it's got a square root.
You got it. You got it. So back over here to my derivative.
Can I just say really quick?
Yeah, say.
That when you draw 11 and then a fraction bar, it kind of looks like a smiley face. Except not a smiley face because it's not smiling. You see what I'm saying? Like 11, and then it's like a smirk, but not really a smirk
face.
Like
when Mr. Altstad found the paper blocking his door today.
Yeah, it's a very similar face actually.
You can see a picture of that on Twitter if you go to @HazelwoodMath.
Yeah.
So what we're going to do then is we're going to have arctan of u, which is not a derivative yet. So I'm going to actually take this part off. We're not going to do that just yet.
No,
we're going to go ahead and leave it with y equals. So now my derivative, dy dx, is equal to 1 over u, or 1 plus u squared.
1 over 1 plus u squared times the derivative.
Dx. And we already noted previously what those things were. So I'm going to substitute in for u, 11x square root of. I'm going to substitute in for du dx, this whole guy over here.
Right.
So what we're going to end up with is 1 over 1 plus u. Here's my u.
Which is square root of 11x. Ooh, but we get to square it. That's nifty.
Squared. Wow, it's amazing.
That's super nifty.
Times du dx, which is this hot mess right here.
Yeah. Smirk face over.
Smirk face over some junk.
Okay.
And to make it pretty,
simplify.
We're going to simplify it by multiplying on the top, which gives us 11. On the bottom, I'm going to have 2 times the square root of 11x. Doesn't really simplify, so that's
leave that
2 square roots of 11x times then 1 plus 11x. How did that happen?
The square root and the squared cancel each other out.
Bingo, bango, bongo. And your solution on this guy looks like where we just got to. And there's really no way to simplify this and
actually make it simpler. Yeah, you can multiply out, but that doesn't actually really make it simpler.
It doesn't make it simpler. This is totally a good answer for this problem.
Leave it.